IITJEE Olympiad and AP Physics with Ambarish, and in this video I have brought another exciting challenge for all of you, in which you are playing the role of a military engineer in the army of none other than Chhatrapati Shivaji Maharaj. So here's the challenge. Satara, November 10, 1659. The troops of Adilshah are rowing along Koyna river, only to be crushed to smithereens by the strategically waiting cannon of Chhatrapati Shivaji Maharaj. The Adil Shahi troops are carrying rocket launchers which can fire with the speed u, and the cannon can also fire with the speed u in every direction. Calculate the distance along the river over which one-sided battle can take place. That is, the cannon can attack the enemy but not the other way round. Treat the hill like a wedge of inclination theta and steepest slant height L, and the cannon is on the top. The river flows along the base of the wedge. Treat cannon like a point object and the river like a line along the base of the wedge, perpendicular to the line of steepest descent. So this is the challenge. Now here you can see this is a hill on which I have placed a huge cannon. It's supposed to be treated like a point size cannon, but just for graphic effects you can see there's a huge cannon over there, and this is the inclined wedge, and there's a river flowing over here. So Adil Shah's troops, they are coming along this river, and you know that when they're sufficiently near, then the cannon will be able to hit. But if they come too close to the cannon, they'll also be able to hit the cannon. The challenge is that we have to find the distance along the river where the cannon can hit the troops, but the troops cannot hit the cannon, and this is to be treated like a wedge. So if you want, you can try this challenge for 5 to 10 minutes, and then you can have a look at my solution right away after this. Alright, so let's get to see the solution. So before I get into the solution, there are certain facts that you need to recollect from your IITJEE physics. So this is the standard result that we do with projection on inclined plane in IITJEE physics. That is, for projection down the inclined plane, the range is maximum for a projection angle of theta is equal to pi by 4 minus beta by 2. From horizontal we are projecting, and if we want maximum range down the plane, the angle of inclination theta should be pi by 4 minus beta by 2. And if you plug in this value for projection angle, the corresponding maximum range is given by r is equal to u square upon g into 1 minus sine beta. So this is the standard result that you will be needing for this problem. Alright, so this is for projection down the plane, the optimal trajectory. Now another thing, a similar result you can also write for projection up the plane. Suppose you are firing a projectile from the bottom and it's reaching somewhere to the top, and you want the maximum range up the hill. So then the angle of projection has to be theta is equal to pi by 4 plus beta by 2, and the corresponding range is given by r is equal to u square upon g into 1 plus sine beta, where beta is the inclination of the hill and theta is the angle of launching from the horizontal. So these are the standard results that you do in your standard theory of IITJEE when you study the projection along the inclined plane. So I'll be using these results, and the derivation is not very complicated. It's very simple, can be found in almost every IITJEE textbook. Alright, so keep in mind these two results, and we are going to use them for our solution on the next slide. And yeah, so this is our geometry. This is the standard theory, and we are going to apply to a little bit. This geometry is a little bit different from the standard geometry. So here we have the cannon, and this is the river coming along this x is the distance along the river, and suppose x is the maximum distance along which our cannon can fire. So we'll try to evaluate that, and this is the range on the inclined plane then. Alright, so let's look at more details in the next page. So suppose the cannon is firing, and let's say x is the maximum coordinate along the river. So river is along this direction. X is the maximum coordinate along the river which can be hit by the cannon. So then r should be the maximum range along the inclination beta. So now what I mean by that, instead of thinking it like an inclined plane of slant height L, we can also imagine another incline along this, another slope of angle beta along which my projectile is going. The projectile doesn't know that where it is going to hit the incline. So I can as well imagine an incline of inclination beta. This is the vertical height, which is L sine theta, and this is the diagonal of the base of the wedge, you can say. So now I am saying that if x is maximum, then this r should also be maximum along this inclined plane. Why? Because if it can hit at a distance more than r along this incline, then obviously by turning the projectile a little bit further, then we can get a greater value of x also. So that means what, this r is also the maximum range along the incline of inclination beta. Okay, and we can use the same result here now. R is u square upon g into 1 minus sine beta, where r will be what, you know that this slant height is L, this distance is x, so r is under root of L square plus x square. And sine beta, again you can see this is a right triangle. From the blue line, the vertical and this dotted diagonal of the base, this angle is going to be 90 degree, and sine beta will then be L sine theta, this is the vertical, and divided by under root of x square plus L square cos square theta, because this is L cos theta and this is x, so dotted line, that is L square cos square theta. Okay, x square plus L square cos square theta under root. So now this is the result, and we can just plug in the value of r over here and sine beta over here, and then we can solve for x, for the maximum range. So upon substituting and solving for maximum x, we get the value of x as under root of u square by g plus L sine theta whole square minus L square. Looks a bit complicated, but it's when you solve the equation, it's not very complicated. We can easily get this result by just a little bit of mathematical manipulation. You get this result. So if my cannon can fire the maximum distance equal to this much. Now I want the result for one-sided battle. So Adil Shah's troops, they'll be coming somewhere over here. They are firing from lower height to a greater height, so that's why they have to be nearer to the cannon. From greater height you can fire farther with the same velocity, but their velocity is, projection velocity is u, but then they have to fire up the hill, so therefore they have to come nearer somewhere. There will be some distance over here from where they will also be able to fire on the cannon. So now that distance can also be similarly found. So if you look at the formula on the previous slide, here instead of g into 1 minus sine beta, it would be g into 1 plus sine beta, and accordingly by making proper substitutions exactly in the same method, we can find the distance, maximum distance from which the troops can also fire, Adil Shah's troops can also fire on the cannon. And if you calculate that, you get a symmetric expression. Let's say x prime is the distance from which the Adil Shah's troops can also fire, then we can get the total distance for one-sided battle as x minus x prime. So what do we get there? So x minus x prime, if you calculate, you get x is this, and x prime you get by putting a minus sign instead of plus sign over here. That maths is very simple, and then you subtract and you get the final result. So this is our final answer, and we'll be able to crush the Adil Shah's troops if we catch them in this interval of distance somewhere there. Okay, so one-sided battle can take place. I hope all of you liked this video, and if you did like this video, please do subscribe to my channel if you have not already subscribed, and please share it with your friends. If you're a student, please share it with your peers who can benefit from these puzzles, these challenges. And if you're a teacher, please share it with your students for intellectual stimulation and enhancing their physics understanding, and do give it a thumbs up. That's all for this video. See you in the next video. Thank you very much.